So very good morning to one and all present here. Today we are in module number 4. So in the previous module number 3, so we discussed about a few problems from Lamy's theorem. So to interrelate the principle of concurrent forces, which is acting on a rigid body. So we have solved a problem based on system of forces. Then at last we saw about principle of transmissibility law of forces. These are some of the basic concepts we underwent up to module number 3. Now in module number 4, so we are going to proceed with parallelogram law of forces and a few practical application where we can apply the parallelogram law of forces. So this and all we are going to discuss in module number 4. So first let us see the derivative part of parallelogram law of forces, and then we will catch up with the practical part, real-time application about the concept. So it is a known fact that force is considered to be a vector quantity. It has both direction and magnitude. So a parallelogram has a closed figure with 4 sides. All the sides are equal and facing opposite parallel to one another. So by applying the parallelogram law of forces, one can able to calculate the resultant force which are acting between the two adjacent sides of the parallelogram on a point particle. So this can be graphically illustrated by in this way as shown in the next slide. Let O be the point on which two forces P and Q are forming the adjacent sides of the parallelogram. So from this we need to find out what is the resultant of the forces P and Q by applying the parallelogram law of forces. So what is the statement applied here? If two forces are acting at a point O are assumed to be the adjacent sides of the parallelogram in magnitude and direction, then the resultant force both in magnitude and direction is said to be the diagonal of the parallelogram, which starts appearing at point O. So this can be further given by a complete explanation. So OC is the diagonal line or the resultant of the two forces P and Q, where beta is the angle between the line OD and OC. Theta is the angle between the line OD and OB, where P and Q are the forces which are situated on adjacent sides of the parallelogram. So the diagonal of the parallelogram OACBO, from that OC stands for the resultant force R of the two forces P and Q. The angle of the resultant R from the line of action of the force P be beta as described here. The line segment AD is an extension of the line OA. So AD is a line segment which has been drawn from the line OA. And the DC is the line passing through the vertical point D. Since the sides OB and AC are parallel, both are considered to be parallel. AC and OB are facing parallel, equal and opposite, equal in equal length. Both AB and AC are parallel in nature, having equal length of measurement. Further, let us consider the triangle, right angle triangle ADC. So ADC forms a right angle triangle. take DC is equal to AC into sine theta. The sine DC is equal to AC into sine theta. Similarly, AD is equal to AC into cos theta. So in place of AC, you put the force Q. We know that P and Q are the two forces acting on the adjacent sides of the parallelogram. So we consider that OB and AC, both the force vector is considered to be Q. So when the force resolved vertical horizontal means we have to put sine theta and cos theta. These are the basic rule of thumb to be calculated, resolving the forces vertical and horizontal component. Now OD is equal to OA plus AD. So now this can be written as P plus Q into cos theta. So OA is said to be P and AD is Q. Here it is written here Q into cos theta. So in place of AD, you apply here Q into cos theta. Now P plus Q into cos theta. Okay. So now you take right angle triangle ODC from the figure ODC, right angle triangle. So square on both the sides. OC square is equal to OD square plus DC square. So OC is the resultant. R square is equal to, in place of OD square, you put P plus Q cos theta whole square plus Q into sin theta whole square. This looks in the form of A plus B whole square. So you expand like this. P square plus Q cos theta whole square plus 2PQ into cos theta plus Q square into sin square theta. So further we can elaborate the next step. P square plus Q square cos square theta plus 2PQ cos theta plus Q square sin square theta. Now bring the common term outside. P square plus Q square within bracket sin square theta plus cos square theta plus 2PQ cos theta. We know that sin square theta plus cos square theta is equal to 1. So apply 1 here. Final equation can be written as P square plus Q square plus 2PQ cos theta. So this is the resultant resultant force equation for parallelogram law of forces. So take square root, R is equal to square root of P square plus Q square plus 2PQ cos theta. Find the angle of the resultant force. This is given by the equation tan beta is equal to Q sin theta divided by P plus Q cos theta. Using both the formula, we can able to find out the solution. Now, let us see the practical application where to apply the law of mechanics, the parallelogram law theorem. You take a tabletop disk. Okay, so it has two inclined legs. The tabletop disk has two inclined legs supported with a base rigid platform, and it has a top lid which is covered on both the legs, above the legs. Okay, so here force F1 and F2 are the two adjacent forces acting along OA and the AB, right? Where OB is the resultant force. So by applying parallelogram law of forces, so we can able to find out what is the resultant force OB by considering F1, F2 are the two adjacent force forming on two adjacent side of the parallelogram, OA and OC. Okay, this is just a small practical application where to apply the theorem in real life object. So with this, I thank each and every one of you for your kind support and encouragement. In the next meeting, we will discuss about some more additional example, the same subject, engineering mechanics. So thank you one and all gathered here.